So, good morning, everyone. We are grateful to you that you join us this morning to listen to our speaker. And I would like to introduce him to you guys. Actually, you will have great opportunity to listen to some information from a representative of IT company Infopulse. This is Alexey Ostapov, test automation team lead at Infopulse, and also he is a speaker on the podcast DO. Topic for today is we don't know how programs work, and we will find out a lot of information about why should a developer know mathematics and algorithms even if there are frameworks. We will find out 8 aspects of software quality and how and why you have to test your own and other people's code. And now the floor is for our speaker, Alexey. Welcome.
Thank you, Daria. Good morning, everyone. Okay, I need to warn you, English is, I'm not so good in English to talk fluently. And I know that majority of you don't have English as your main language. So don't worry if you don't understand something, do not hesitate to ask. You can type your questions in the chat and I will answer all of them in the end. And let's start. Do you see my screen? My presentation? Okay, that's good. So, hi again. It's such a pleasure to be here. Today, I want to talk to you about the fact that we often don't fully understand how software works. Actually, we don't know how software works. But first, let me introduce myself. I have a slide. My name is Alexey Ostapov. I work as a test lead at Infopulse, and I have over 15 years of experience as QA professional and test automation engineer. It's important to emphasize because I not only understand how to write a code, but also I have deep understanding of quality assurance. Additionally, I have been teaching students for more than 8 years. And for past few years, I've been passionate about sharing my experience with Ukrainian QA community. Along with my colleagues, we maintain a blog called QA Mania. I will share the link to it at the end of my talk. And furthermore, I am one of hosts of the DO QA podcast. It's a podcast about quality assurance. It's really awesome. Okay, and let's get back to the topic. You might be thinking, this guy is just a tester. What could he possibly tell us about software development and on a programming Olympiad? And it's a really good question, but I have a good answer for you. I've seen the development process from various perspectives and gained many insights that I would like to share with you. So, firstly, let's talk about importance of math and algorithms. There is a common misconception that knowledge of math and algorithms is overestimated and unnecessary in our daily routine as developers. I've prepared a slide, you can see it right now, with pros and cons of understanding these concepts. Let's start from cons, as they are quite compelling. Firstly, one of my favorite arguments, math is not needed to develop yet another e-shop or web application. Secondly, there are already numerous frameworks and libraries developed by people much smarter than me. All the necessary math already incorporated into these libraries and frameworks. So I just need to use them in right order. I don't need to know it myself. In case of some extraordinary task, I can always ask ChatGPT for assistance. And another, my personal favorite, I am smart enough and I can learn math anytime if I need it. And now let's talk about advantages of knowing math and algorithms when you're developing software. Firstly, it provides me with the necessary terminology to better understand and describe problems I encounter. My typical problem that I do not know how name things I encountered and how to Google some answer for this. And knowing math give me a broader context. I'm aware of multiple solutions of each task and can compare the advantages and disadvantages. And I take algorithm limitations into account when choosing the most suitable one. So I am so fascinated by the limitations imposed by typical programming Olympiad task, such as completing a task within a given time frame. So not just do the solution, but do it in no more than 5 seconds. It's awesome. In this situation, finding and implementing an efficient solution becomes crucial, not just any solution. It's so cool. If we consider in some basic examples, sorting algorithms come to my mind. I like some simple examples. When I was younger and studying at university, I discovered that each sorting algorithm has its own complexity, described as or a function, it's n logarithm n or n squared or just n or something like that. I wondered why we need so many different sorting algorithms when there is only one correct result in the end, sorted array. Couldn't we just use the most efficient algorithm and be done with it and be happy? However, the reality is not as simple as sorting speed, and stability also depends on data quality we provide, data size, available memory, and if you are winning something like speed of sorting, something you're losing. Unfortunately, you don't even know what you're losing and what consequences it might have. Some algorithms become inefficient with large amount of data, while others consume excessive amount of memory, which makes them useless if you are running your algorithms on less powerful hardware. Allow me to provide a real-life example. My team and I were developing banking software, and we designed it robustly. I'm really proud. It was awesome. Implementing a multitude of tests to ensure the correct functioning of all its features. However, when we delivered our software to production, so end users can use it, it started to fail. Surprisingly, the reason for these failures were quite trivial. We had tested our solutions assuming there would be hundreds of thousands of bank operations per day. But the bank started to process millions and even tens of millions transactions per day. Even after moving our software to more powerful servers, more powerful hardware, the issue was not entirely resolved because it's you can just scale up everything and be happy. Additional code changes were required, and we did it in rush. It was a nightmare. Secondly, I have noticed that developers often focus solely on writing code to ensure that software meets the expected functionality. So you have a task and you're writing a code to solve issue. However, we cannot rely on this approach. There is a standard ISO 25010, which defines software quality and identifies 8 characteristics to consider. You can see them on the screen right now. Good developers, the best, the best of the best, may take into account a few more quality characteristics, such as efficiency and reliability, as I mentioned earlier in my example with sorting algorithms. Even in this case, 5 more quality characteristics left. Here's the full list, and with simple definitions by me. So first of all, it's functional suitability, the degree to which the program provides functions that meet user needs. Actually, that's what program does. Performance efficiency, the degree to which program utilizes resources over time. It's how fast, how efficient program works, and how many resources it utilizes. Compatibility, the degree to which program can work with other programs. Usability, the degree to which program can be used by specific users. And all these characteristics standard is describing, all of them are measurable, or you can define some scale for each attribute and say this software is has 95% quality, something like that. You can measure all of this, even usability. Reliability, degree to which a program can fulfill its function regardless of possible errors. Security, the degree to which a program protects information. Maintainability, the degree to which a program can be modified, corrected, or adapted. And last but not the least, portability, the degree to which program can be used in different environments. If we're talking about some specific software, if we're talking about portability, you need to think how to run your code, for example, on different operating systems like Windows, Linux, macOS, Android, iOS, so on. If your goal is to run it on broad variety of devices. And security, nobody thinks about security until it's too late and your data is stolen. Okay, and compatibility. You are installing you are writing your software and you are running it on your PC on isolated environment, and then you are giving your software to testers. They running the same code, and usually this code is not running well, or it's throwing a lot of errors because they have different environment and the different software installed on their environments, which can influence your software. Thirdly, let's talk about frameworks. As I mentioned before, there are numerous frameworks available for complex tasks. Nowadays, nobody builds software from scratch. However, using frameworks can sometimes lead to losing context. Some configuration parameters are implicit, and different frameworks version might be incompatible with each other. I recall developing a web application, simple one for my needs, that utilize multiple frameworks for web request handling, database management, security, caching, and more. My solution was designed correctly according to the documentation, but I encountered numerous errors every time I tried to run my own code. After hours of searching on the internet, I discovered that I need to downgrade the version of one of frameworks and also explicitly configure some certain parameters. So I had to create config file and put some configuration lines to this file. It was not obvious at all. It was a relief to find the people with similar issues and their solutions on Stack Overflow. So God bless the Stack Overflow, actually. When you design your software, always keep in mind hardware specification. If you have a powerful laptop, powerful PC, it's awesome, but your solution can run on some Raspberry Pi, whatever. It's a low memory, weak CPU, and your software can run in different way. Operating system, even if you are developing on some Windows 11, for instance, your code can be executed on some Windows 10, Windows 7, Windows XP, who knows? Or if we are talking about some web applications, we are approaching to use the latest version of web browsers, but still there are some people in the world who are using Internet Explorer 6. So be aware. Network connection. I am old enough to remember web applications were working on dial-up internet connection. So it's so slow speed. Such speed nowadays means you are offline, so nothing will work because all software consumes some internet connection and requires some minimum speed to work. Already installed software and its compatibility. Typical antivirus or firewall problem. It can ruin your life because you're running your code and it's not working without no reasons, and you would be lucky if antivirus would say, hey, this code is malicious or suspicious. I won't allow it. Implicit and explicit configuration settings. It's the worst, I would say. because all frameworks each framework is developed to be user-friendly to you, developer-friendly, I would say. And they hiding all configurations to some files. And even you don't need to create some configuration because it's implicitly already configured somewhere. And you can run your framework and it doesn't work or it is working in some wrong way. And you need to find solution, search for some parameters, how to name file, where to place configuration file, what parameters should be there, in what order. It's really painful. And version compatibility. Usually, there are some popular version and of some frameworks, and in the documentation you can read that if you are using this framework with this framework, use version number 10, whatever. So just be aware that not all versions are compatible with all other versions. Would you like to hear my favorite tale about software context? Of course you do. In 1966, the Soviet Union attempted to launch a Soyuz spacecraft. However, the launch was unsuccessful as the engines did not start, and the rocket remained stuck on the launch pad. Interestingly, in a matter of minutes, the emergency system started. You can see it on the picture, this pointy thingy in the end of the rocket, it's emergency system. In the case of an emergency, there are some engines on this pointy thingy, which disassemble spacecraft with all equipment and with astronauts, cosmonauts, and throw them away. If rocket explodes, cosmonauts will leave. So it's the main point of emergency system. After a few minutes of this unsuccessful launch, the emergency system designed to save spacecraft launched. An analysis of this incident revealed that emergency system should have only started in case if rocket position deviated from planet trajectory. However, rocket not moved, but it moved. Earth rotation caused non-obvious movement, and gyroscopes tracked this movement, detected it, and reacted according to the program. So as you can see, context is always broader than you might initially imagine. So rocket is not, it's static if we are comparing it position to Earth, but it's not static according to the universe movement and solar movement, the Earth around the sun and the Earth around itself. So it's a mega context, and we need to keep in mind all this stuff when we design our software. I believe the designers of this emergency system haven't thought that such situation can ever happen. And lastly, most importantly, nobody knows exactly how software works. Allow me to provide an example from my current project. My team is designing new software for new banking software, completely different from the previous example of banking software. And we are selecting programming languages, technology stack, and development patterns to be used. Actually, the list of frameworks to be used. Theoretically, all the candidates should provide good functionality in efficient manner. Therefore, our developers created a few minimum viable products called MVPs that we can test and compare the results. Surprisingly, the technology stack that was theoretically expected to be the fastest and the coolest performed poorly and crashed without any apparent reasons. My testing team helped to find out capabilities and limitations of each approach in practice. And it's so awesome. So even developers who developed this software according to theoretical limitations didn't know actually how their software would work, and only tests can reveal how it works in reality and what limitation it has. You may know the best solution in theory, but only by testing it by yourself, you can truly prove it worth. Therefore, I encourage you to always test your own code. And to summarize all my speech, here are a few recommendations to become a better developer. First one, acquire knowledge of math, algorithms, and design patterns to explore multiple solutions for any given task in advance. Second one, familiarize yourself with software quality standard and understand how to measure quality of your program. So it's not only functions, it's not only efficiency. There are eight characteristics you need to consider to make a good quality software. Third one, constantly study and stay updated on the latest technologies. The field of IT evolves rapidly, and failing to study new technologies can lead to stagnation or even degradation. Continuous learning helps you to understand the broader context because frameworks are advancing and more configuration becomes implicit. So if you don't understand how does it work inside, you're screwed. Test your own code to understand its capabilities, limitation, and behavior. Test not only what program does, but also how it performs its functions in line with the standard of software quality. And create MVPs, and do not hesitate to experiment to achieve better results. But remember, the difference between the product and the MVP is quality of what you are doing. And it's bringing me to the end of my presentation, actually. If you have any questions, I will be glad to answer them. So you're welcome. And this is, by the way, my blog, Mania, website, YouTube channel, and Telegram channel, where I post the most of different QA information and sometimes some developer stuff. Okay.
Hello, thank you for your presentation. And I would like to ask, so you said that we need also to understand how the program works, like behind all the process, and sometimes it is confusing till which level we need to dive deep. I mean, we need to know how it works on level of documentation to explain everything, or we need, for example, to dig to the assembly level.
Well, it's a good question. It's always related to make things rational. So if you have time and resources to dive deep, do it. If you don't have time, you're limited. You need to provide your solution in some time frame. Do the best you can. So deep dive on the level. You can understand more context of how your software works. But take time into account. So if I would have, for instance, 40 hours, it's one working week to test some functionality, I would spend all this time to understand the context. Even if for some functional testing and non-functional testing, I would need about half of this time. The rest I would spend to understanding better context. So like environment in which will be used for this software, and all context which can be useful.
Thank you very much for the answer.
You're welcome. Okay, no more questions. Okay, maybe I can tell some more tales. I actually like tales. I talking a lot when I am providing lectures in KPI or just in the internet, and I have my list of favorite tales regarding context. Actually, everything regarding context. One of my favorite, it's related to Mars Climate Orbiter. Maybe you know this one. Actually, NASA spent years and years of time and millions of dollars to build a spacecraft and send it to Mars to discover climate on this planet. And they ordered a program, a flight program, to some British institute. And the spacecraft was state-of-the-art, and software itself was state-of-the-art. And NASA launched the spacecraft. It was flying to the Mars, and when this spacecraft was there, it was just crashed on the Mars. And investigation shown that everything separately was a state-of-the-art, but appears that spacecraft was built in the United States, and it was using metric systems in its computers for calculation. But program designed in Great Britain was using imperial system. So it's some duriums, inches, and feet, and so on. So it became the program was incorrect because software expected imperial data, but hardware provided all data in some metric system, and this inconsistency caused to wrong trajectory and wrong flight program in the end, and satellite was destroyed. So, and actually I love this story very much, because it shows that even if you test part of your software and you are good in it, and you make sure that this software works, when you try to join your part with other parts, and can fail in any moment because some unexpectedly thing you can't even imagine. So I always encourage all my students, all my colleagues to look broader and try to understand context deeper, because even something trivial for you might be not obvious for your colleagues, for your friends, for everybody else. So try to do all your work explicitly. That's why I like Python programming language, because it states that in its Pythonic way, it's do all your code in explicit way. So no some hidden configuration. Everything should be clear and understandable. When you read the code, you understand it, what it does, and it's awesome. Okay, guys, if you don't have any questions, or you have questions and you just hesitate to ask them right now, you can ask me later anytime. Just contact me in the blog. And for Ukrainian-speaking audience, if you want to hear it again or read it again, probably I will publish my presentation to the blog and to the DAO portal. So you're welcome. Ask your questions later then.
Thank you very much.
Okay, thank you for your attention and for your time. Have a nice and safe day.
Any questions?
Really, I want to ask one, just trying to remember my English. So,
We will help you. Don't worry.
yeah. So the question is like about, we were listening about list of some overlooked points which can be overlooked by developers, but like maybe more examples to compare what can testers overlooked and what testers sometimes missed when testing, comparing with what developers can also miss when they are developed and trying to test their code, like black dots in this area. Maybe Alexei can provide some like comparing examples.
That's a good question. Actually, you can't even imagine how many crucial issues I've missed. How many times I really fucked everything up. Sorry for my English, because but it's normal. It's not possible to test everything. You just need to admit it and live with it. The good points that developers and testers have quite different mindset, luckily. Developers are focused on build software which fulfill some requirements. So doing some functions and do it in some right way on some in some conditions, like I'm building applications for Android because I know that users will use it on Android phones, something like that. Testers are using software and testing software in the way how users will do it and more. So in right way, like positive testing, in if users doing something wrong with your software, like negative testing, it's really awesome. But developers might miss some obvious issue for them and testers could find them. But also testers can miss something that's not obvious for them, and it's completely normal. But together with collaboration, with cooperation, software developers and software testers, they can deliver software of better quality, just because we have different points of view on the same software, on the same problems. Okay, but if we are talking about some issues to be found, to be analyzed, I would say from time to time I'm attending some interviews to other IT companies because I am curious what about situation in the market. And if it's some positions for automation, testing, and even development, there are some simple tasks can be provided by the interviewers just to verify I am a not really bad programmer. And the typical tasks can be like develop software which can calculate Fibonacci line, something like that. So really simple. Or develop software which can calculate factorial, something like that. And actually, if you open any software development book, you will find that each task can be solved by a single function, like Fibonacci and factorial. It can be done with recursion or without recursion, actually, but it's single function of code. And the issue of both cases that they focus on the function. So we have some number as an input, and we have some number or list of numbers as an output. And these examples in the books are focused only functions. And as I told you, there are a lot of characteristics except of functions. And as a software test engineer, so a quality assurance engineer, I tried a few times to design the same tasks, but you trying to build really software of better quality, I would say. So I designed software not only to calculate factorial number, but so it did its function, its functionality. I've done it with cycle, not recursion, to make it works with a bigger number and do not have some Stack Overflow issue. So I made it efficient and also used some algorithms. So it's not just, how would it say? I've got it. So actually I've used caching. So each time you use your function, you cache the biggest factorial number you've got. So next time you're trying to calculate something else, software actually do not calculate. It's taking cache. It would be more resource efficient. Also, I made it reliable. So I put some validations for negative numbers, not in numbers, and so on. I put it to some simple console interface to make it user-friendly. So I increased usability of this program. I put this program I developed this program in the way it can be run on Windows, Linux, macOS, whatever, and it was compatible with different versions of Python itself. So I put it like from Python 3.6 and higher, any version would be applicable. So I tried to implement all my knowledge about software quality to the single task of finding factorial number. It takes some more time, but as a result, I was really pleased that I tried to not only theoretically know that I can do this software, but I actually implemented all my knowledge to the simple and trivial task like factorial.
Thank you for providing examples.
Any other questions, guys? Okay, may I have a question to you?
Sure.
How did you start your professional career at IT field of education? Why did you decide to do this?
By accident.
Really? What kind of,
Yeah.
if it's not a secret?
It's not a secret. Actually, I always wanted to be an IT engineer, but 20 years ago, I haven't decided to be what kind of IT engineer I want to be, because I didn't knew a lot about IT actually. But I was started to study my higher education at National Aviation University in Kiev on faculty of computer science and computer networks.
Mm-hmm.
So and at that time I was passionate about software networks and decided it's good to be a network engineer. But after a few years of studying, I decided that I like software development more. I like programming, and I created a CV resume for software developer position and came to Infopulse 15 years ago. And the Infopulse recruitment said that I am weak. I'm too weak to be a software developer, but I am curious enough to and smart enough to be a software tester if I want to be a software tester. And what the hell, I was a student and it was a good experience, some money, it was awesome. So I agreed. 15 years ago, there was no understanding what software testing is in Ukraine. Actually, it's now we have hundreds resumes, hundreds CVs on the single position of QA engineer, because we have much more engineers that market is needed. But 15 years ago, just random a guy from street can be QA engineer if just he wanted, and I really wanted it. And my plan was, okay, for a few years I would be a QA engineer, and then I will switch to software development. But it appears that software testing, it's so awesome, it's so cool, and so much opportunities for me, so actually I enjoy my job so much, so I don't want to switch anymore. I still enjoy software development. I can develop in various programming language. I started from Pascal because everybody starts from Pascal. Then it was JavaScript, C#, Java, and now it's Python. But actually, language is not so important. It's software development mindset. It's really matters because algorithms matters, math matters, and the language, how to implement your algorithms, is secondary or even not really important. But I enjoy to develop software, but I enjoy more to test it, to imagine conditions, to imagine how can I measure software quality of any software I encounter. It can be some mobile, it can be some desktop, it can be some web, it can be some spacecraft, whatever, or even some neural networks or artificial intelligence stuff. Because it's ChatGPT is also software, and I sure that there are some QA department who is testing this ChatGPT before publishing it to mass market. So I'm so excited about the future of IT and how many things I can do here.
Thank you a lot. It's very inspirational. Maybe someday some of students will do the same things as you and come to Infopulse with
Hope so.
a weak CV, but then in 15 years
Yeah.
will become a professional tester or someone.
Yeah. Actually, sorry for interrupting. Actually, like in Kung Fu Panda, there is no any secret ingredient. You just need to enjoy what you are doing, whatever you are doing, and it would be awesome.
Yeah, I completely agree with you. Thank you for this presentation and information that you have shared with us. I'm sure that it was very useful for our participants. Guys, if you have any questions, you may ask them. Something we have in chat. Thanks a lot, Alexei.
Thank you for listening.
If you don't have any questions, maybe we will let our speaker to go and do his tasks. This webinar is recorded and will be posted on the website of our Olympiad, and we will share with you, Alexei, also.
Okay, thank you.
Thank you.
Have a nice day.
Thank you a lot.
Bye-bye.
So the next webinar will start at 12:30. So join this link and meet another speaker. See you. Bye. Thank you a lot.
Yeah.